Hey everybody, welcome to Algebra 1-2, Section 7-3, more multiplication properties of exponents. I call this the power rule. By the end of this lesson, you should be able to use the power rule with variables. You should also know how it works with coefficients. You need to understand the difference between the power rule and the product rule. And lastly, you need to be able to use both rules together. So let's take a look at the power rule. So this is what the power rule looks like. You'll have one term with an exponent on the outside. Okay, that's different from the product rule where we had two separate terms, usually with the same base, being multiplied together. So here it's one term raised to an exponent. Make sure you know the difference in how those two rules look when you look at the problem. So let's go ahead and do this one the long way, and then we'll see if we can come up with a shortcut. So if I have x to the fifth raised to the third power, that literally means x to the fifth times x to the fifth times x to the fifth. And that looks like our product rule, where we've got different terms and we're multiplying them all together. So our product rule tells us to add up those exponents. So 5 plus 5 plus 5 is 15. So that's our answer, x to the 15th. Now take a look at the original problem, take a look at the answer, and see if you can come up with some sort of shortcut. Well, if I take a look at that, I'm thinking that our rule is going to be that we multiply the exponents. And that's 100% correct. There's going to be two parts to the power rule, and the first one is multiply the exponents. So let's take a look at a few examples here. A to the 9th to the 5th. Multiply those together, a to the 45th. B to the negative 4th, and then that's raised to the negative 8th. Multiply those exponents together, and you get b to the positive 32. C to the negative 5th squared. Multiply those exponents together, and you get c to the negative 10th. However, we can't have negative exponents in our final answer. So we have to make that thing change its location, and the final answer is 1 over c to the 10th. Okay? Now, what happens when we have coefficients involved? Remember, coefficients behave differently than exponents. So here we have 3x to the 8th, and that whole thing is raised to the 4th power. So think of it kind of like the distributive property, where the exponent affects what's directly sitting on. So that x to the 8th, the 8 is only affecting the x. But that 4 as an exponent is affecting everything in the parentheses. So that 4 affects the 3, as well as affecting the x to the 8th. So if you want to visualize it, you can think of it as 3 being raised to the 4th power, and then x to the 8th being raised to the 4th power. So 3 to the 4th power is not 12. I don't do 3 times 4. I do 3 times 3 times 3 times 3, which is 81. And then our first rule is multiply the exponents, so I get 81 x to the 32. So what rule can we come up with for the coefficients? Well, the coefficients work just like regular coefficient problems. You just take that coefficient and raise it to the outer exponent. So that's the second part of the power rule, is the coefficient, just raise it to that exponent. So let's do a few more examples. 2x to the 9th to the 3rd power. So to visualize that, I have to do 2 to the 3rd power and x to the 9th to the 3rd power. So 2 to the 3rd power, 2 times 2 times 2 is 8. And then x to the 9th to the 3rd, multiply those exponents, and I get 8x to the 27th. 3, y to the negative 5th, and all that to the 6th. So let's visualize it. Take that 6 and apply it to the 3. Take the 6 and apply it to the y to the negative 5th. So 3 to the 6th power, let's see, that's not 18. I got to do 3 times 3 times 3 times 3 times 3 times 3. So I believe that is 729. If not, use a calculator. Figure it out. If you don't know how to use the exponent button on your calculator, ask me in class, and I'll be glad to show you. And then y to the negative 5th to the 6th, multiply those together, and I get 729 y to the negative 30. But again, we can't leave that answer with a negative exponent. so I have to make it move its location. So that 729 is cool to stay where it is, but that y to the 30th moves to the denominator. So final answer is 729 over y to the 30th. 6z to the 7th to the negative 2 power. Okay, distribute that negative 2 to everything in the parentheses. So I get 6 to the negative 2, and then z to the 7th to the negative 2. So 6 to the 2nd power is 36, but because it's a negative exponent, it has to move to the denominator. So that 36 goes to the denominator, and then I get z to the negative 14th. That has a negative exponent. That needs to move to the denominator. So final answer on that one is 1 over 36z to the 14th. Okay, let's take a look at a few more examples and see if this makes more sense. Okay, so now that we've got the hang of the general power rule, I want to fire through these relatively quick. So I've got 2 to the 4th as well as n to the 4th to the 4th. So 2 to the 4th is not 8. It's 2 times 2 times 2 times 2. So 2 times 2 is 4. This 2 times 2 is 4. And 4 times 4 is 16. And then multiply the exponents. And I get n to the 16th. Let's do another one like that. 6b squared squared. So that means 6 squared times b squared squared. So 6 squared, 6 times 6 is 36. And then b squared squared, multiply those exponents, and I get b to the 4th. Now, after doing this for a while, you'll kind of get into a habit of it. And so I want to see how quickly you guys can do these problems. My guess is once you get the hang of it, you'll do all right. So I'm not going to write it out, visualizing, distributing the exponent. I'm just going to do it. So 3 to the 4th is 81. A to the 4th is just a to the 4th. And then b to the 4th is b to the 16th. And hopefully you'll get to a point where you can go ahead and just fire through these and get the answer pretty quickly. So 5 to the 3rd is 125. M to the 3rd is just m to the 3rd. And then n to the 3rd is n to the 9th. Final answer. Okay, let's do another one like this. 6 squared is 36. Y squared is just y squared. And x to the 4th squared is x to the 8th. Okay? Now, a few more examples that I want us to do. Okay, yeah, let's go ahead and do this one here. 2 to the 4th, 2 times 2 times 2 times 2 is 16. X to the 4th is x to the 16, and y to the 4th is y to the 16. But this next one, this 13, this is one that I really want to emphasize here, okay? Because there's two problems here. I want you to spot the differences between the way these problems are written and then what we do to solve them. So here I'm noticing I don't have parentheses with an exponent on the outside. That's a dead giveaway that you're going to use the power rule. Now over here written in blue, I sure enough do. I've got parentheses and an exponent outside the parentheses. I'm definitely going to use the power rule here. But because I don't have an exponent outside the parentheses here, I'm not going to use the power rule. Instead, I have two separate terms being multiplied together. That's the product rule. Now, these two problems look very, very similar, but because they're written differently, we're going to do them differently. And you need to know the difference between the two. So let's do the first one. I've got two separate terms being multiplied together, so that's the product rule. So I multiply my coefficients, 3 times 1 is 3. And then I add up my exponents. 5 and 2 make 7. So the fact that it's the product rule changes what we do to those exponents and coefficients. We multiply our coefficients and add up the exponents. Now in the second part of the problem, it's not the product rule, it's the power rule. So I have to take 3 to the second power and then multiply the exponents. So even though the original problems look very, very similar, because they're different, we get vastly different answers. So make sure that you know the difference between how to do the product rule and how to do the power rule, because each rule by itself isn't bad, but you have to know the difference between the two to know which set of rules to use. Okay, one last example. Here I've got two terms. I've got 3x to the fourth times y, multiplying 2x to the third, y to the fifth, all raised to the third power. So I have two separate terms being multiplied together. That's the product rule. But I also have this exponent outside the parentheses. That's the power rule. So here I have to use both rules at the same time in the same problem. So how do you know which thing to do first, the product rule or the power rule? Well, the product rule is multiplying two terms together, whereas the power rule is dealing with exponents. So PEMDAS, please excuse my dear Aunt Sally, tells me I have to deal with exponents first, and then I can deal with multiplication. So I'm going to temporarily ignore that 3x to the fourth y, and I'm going to focus on just the exponent, doing the power rule. So 2 to the third is 8, and then x to the third is x to the ninth, and y to the fifth to the third is y to the 15th. So I've successfully just completed the power rule. Now I can do the product rule. So let's bring that 3x to the fourth back, along with that y. So now I'm going to multiply these two terms together using the product rule. So I'm going to multiply my coefficients and add up my exponents. So 3 times 8 is 24. X to the fourth and x to the ninth makes x to the 13th. Y to the first power, if I don't see an exponent, it's understood to be to the first power. So y to the first and y to the 15th makes y to the 16th. And that is my final answer. So please make sure you know the rules for the product rule, the rules for the power rule, and know when to use each one. That's huge. That's where most people get confused, is they start using this rule where it doesn't apply, or that rule when it doesn't look like it's supposed to. So please know the difference and know when to use them. If you guys have any questions, please feel free to ask me in class or email me, and we'll get through this. Okay, hope you guys have a good one, and I'll see you real soon.